Okay, so for question number 1 here, okay, we got a displacement of a truck that travels 25 kilometers at 20 degrees north of west and then 10 kilometers south. Okay, so the diagram for that one. Okay, so we've got 25 kilometers at 20 degrees north of west. Okay, so we're going to draw a reference line that is, okay, due west. We're going to go 25 kilometers at 20 degrees north of that, so it's a pretty narrow triangle. Okay, this angle is 20 degrees north of west. Okay, this will be our y component, this will be our x component, and this is 25 kilometers long. Okay, and then we need to go 10 kilometers south of that. So the trick with that is it going to get to here? Is it going to be short of here? Is it going to be long of here? Okay, if this angle was 30 degrees, okay, this side would be 12 and a half. Okay, so that would be just getting there. Right, so this is 10. So what I'm going to do is I'm actually just going to calculate what y will be so I know how long to make my 10 kilometer vector. Okay, sometimes we do that just to be on the safe side. So I'm just going to quickly punch in, okay, what that's going to look like. So I'm going to go sine of 20, okay, times 25. All right, so that side's 8.55 long. So that means I need to draw my next line just a little ways south of where the other one stops. All right, so something like that. Okay, that's going to be 10 kilometers, which means our overall resultant, okay, looks like that. And of course, you could draw it the other way as well. Okay, it doesn't really matter. Actually, it might be more logical to draw it the other way. Okay, so your resultants triangle, okay, looks like this. That'll be y. Sorry, that'll be x. This will be y, okay, and this is our overall displacement. Okay, so that's what your diagram should look like. I'll give you a few more minutes to finish the calculations and I'll walk through those. Okay, so for the rest of number 1, the calculations are going to go as follows. Okay, we calculated y already. It was the sine of 20 times 25, which gave us like 8.55 kilometers, and that was north. Okay, the x component will be the cos of 20 times 25. And then, so we'll have the cos of 20 times 25, right, which gives us 23.492 kilometers, and that's west. And then obviously for our blue line, there's only a y component, and it's 10 kilometers south. Blue x is 0. Okay, so for calculating, okay, our green x, or our resultants y and x, okay, our resultants y is going to be 10 minus 8.5505.035.83. Okay, so we're looking at 1.449 kilometers south. Okay, and then our x component, okay, is just going to be our 23.492 kilometers west. Okay, so when we've got those, then we can do Pythagorean theorem to get our overall magnitude of the displacement here. Okay, so we'll take okay, so we're looking at an overall displacement of 23.537 kilometers. Okay, we need our angle. All right, so for me, I'm going to go tan, so it'll be y over x. So second tan of our 1.449496417 divided by 23.492315. Okay, so we're looking at a pretty narrow angle here, okay, of 3.53 degrees. Okay, and so our overall to two significant figures are going to be 24 kilometers at 3.5 degrees south of west. Okay, everybody, is that ringing a bell for everybody? Okay, how are we doing on the boat/plane question? Okay. Okay, so remember, with boat questions, you've got perpendicular vectors. Okay, there's the plane and how fast it can fly going one direction, and it's being pushed perpendicular by the wind. Okay, that'll give you a resultant that should represent your overall average velocity. Okay. Oh, sorry, no, this one goes the other way. Sorry, we're trying to figure out the heading. Okay, so it's going to end up going 318 kilometers due north. So this is our resultant. Okay, that's produced by two velocities. The velocity of the plane, which is, so the wind is blowing due west. So the wind is doing this, okay, at 75 kilometers per hour, okay, which means that our plane must be doing that, so that the wind pushes it back to due north. Right? So all you have to do is figure out what direction the plane is flying. You don't even need the blue line because you have this line and the black line. Okay? And all you're trying to do is find out which direction the plane is going, which is just a trigonometry calculation. Okay? We're going to have the opposite side over the adjacent side. Okay? So we'll have theta equals tan to the minus 1 of 75 over 318, which will give us 13 degrees east of north. Okay? So just like a boat. Okay? A boat's just got the boat speed and the current. A plane's got the plane speed and the wind. Okay? It works exactly the same. All right, let's have you guys try number 3, just because we did a boat question and we were confused a little bit. Okay, number 3 is also a boat question, but it's not quite the same as the other one. It's the other kind of boat question. Okay, so give that one a try here. I'll give you a few minutes and we'll walk through that one. All right, so for number 3, we've got our river. Okay, and we know that we can row the boat at 4 meters per second. Okay, and we're rowing across the river. So we're rowing across doesn't mean we're going across. Okay, so I've got 4.0 meters per second as the rowing speed. I have a current speed going east, okay, at 1.6 meters per second. Okay. So what's your resultant velocity? All right, so we're looking for this along with that. Okay, because that's what it wants, the resultant velocity. So finding that is just a matter of doing Pythagorean theorem. Okay, so that's just going to be the square root of 1.6 squared plus 4.0 squared. Okay, so when we do that, we're going to get 4.3 meters per second. To get this angle, we're just going to go tan to the minus 1 of 1.6 over 4.0, okay, which will give us our 22 degrees east of north. Right? So that's the first part of the question. The second part says if it takes 3.5 minutes to row across, how far downstream do you end up? All right. So, do I not tell you how far it is across the river?
You don't need to know what you don't know.
Oh, right, because I have the time. Stupid. Okay. Yeah, so we got 3.5 minutes. What do I need to convert that to? Right. Okay, so we'll multiply it by 60. Okay, so what do we get for time in seconds there? 310? 210. Let's say 310 is not too much. Okay, 210 seconds is my time. Now that I have that and I know how fast I'm going downstream, that's that number, okay, the distance downstream is v times t, so our 1.6 times 210 seconds, okay, is going to give us 336 meters. Actually, we should only have two significant figures there. Okay, it should just be 3.4 times 10 to the 2 meters, okay, downstream. All right, everybody okay with the boat question? I guarantee you'll see a boat question on your human exam. Okay, as well as a question like number 1. Okay, most likely as well. Okay, how are we feeling about these? Do we remember these? Are we like not too terribly rusty here? Do we need to do 1 or 2 more before we move on to acceleration? Or are we good? How many people want to do 1 or 2 more? Okay, I see enough hands that I'm going to do that. All right, let's have you guys do number 4. Okay, the hiker lost in the woods. Okay, just a strict vector addition question, but they're both angled. Okay, so you got a little bit more calculating to do. So let's say do number 4. We'll see how that one goes, and then we'll maybe move on from there. Okay, so having a look at this first one here. So we've got 10 kilometers at 8.5 degrees south of west, and then one that's also south of west, which is nice because then we know everything. We don't have to subtract anything. Everything's going the same way. All right, so we're going to have a vector that's west, okay, and we're going to go 8.5 degrees south of that, so that's a pretty narrow triangle. So this will be the y component, this will be the x component, okay, that'll be 8.5 degrees and 10 kilometers. And then we've got another one that's also south of west, so I draw a line that's west, and I go 30.5 degrees south of that. So there will be x, y, 30.5 degrees, okay, and then that'll mean that my overall displacement is looking like that. Okay, so that's what our diagram should look like. And now we need to calculate all of our x's and y's. Okay, so black x is adjacent to the angle, so that'll be the cos of 8.5 degrees times 10 kilometers. And black y will be the sine of 8.5 degrees times 10 kilometers. So cos of 8.5 times 10. All right, so we're looking at 9.89 kilometers west. Okay, and then we'll have the sine of 8.5 times 10, which is going to be 1.48 kilometers south. Okay, we have to do the same thing with the red triangle. All right, so x will be the adjacent side, so cos of 30.5 times 7.5 kilometers, and y will be the sine of 30.5 times 7.5 kilometers. Okay, so we're looking at 6.46 kilometers west. And so 5. Okay, so we're looking at 3.81 kilometers south. All right, so now we've got all of our x's and all of our y's. We add them up to get our results, x and y. Okay, so blue y, okay, is going to be our 1.48 plus our 3.81. Okay, and our blue x will be 9.89 plus 6.46. So our overall x is going to be 16.352. Okay, kilometers, and that's west. And then our y, I'm just going to shortcut here, guys, for the sake of time. 1.48 plus 3.81, plus I lost one of the numbers. Okay, 5.29 you would obviously never do it that way. Kilometers, and that's south. Okay, then we can do Pythagorean theorem. So when we put those together squared, right, we're going to get 17 kilometers. And then when we find this angle here, okay, the one I'm actually going to find is going to be the opposite of this because I drew it west of south, right? So I'm going to get 72 degrees west of south, whereas they solved it this way, so they would have got 18 degrees, okay? And you can use any trig function you want for that, okay? I would have used 10 to the minus 1 of the 16.352 over 5.29. Okay, that's the way I would have done it, and I would have got 72 degrees west of south. Okay, everybody all right with that one? Okay. Then let's move on to acceleration.